Hey there everybody, and welcome to the tutorial series where I teach you how to make a cactus in geometry nodes. I'm going to split up every single step into its own video, so expect this to be a couple dozen videos instead of just 1, 2, or 3. So go to part 1. So in the first part of this tutorial series, we need to make the general shape of our cactus, which is going to look like drawing a curve and automatically having some thickness to it. So let me show you how to do that. So in geometry nodes, delete everything, and in geo nodes, I'm going to add in a curve. This is what we are going to use as the thickness object. But for the curve, I can actually delete all of it and use this draw spline tool. That's going to let us draw custom curves. For this curve object, I'm going to make it a geonodes group, and to give it thickness, run a curve to mesh operation, which is going to give it thickness once we give it the profile curve of a circle, which is a bit thick, so maybe give it a radius of a half or even a quarter. The thinner you make it, kind of the more precise it can be with this. And the final thing I want to say is in the curve parameters, you can change the resolution to do that. Next, we need to taper the top of the curve. So in this part, I want to take the curve we drew last time and be able to taper the top of it so it's not just open. And where we left off, our curve looks something like this, right? It doesn't have any tapering. To do this, here's what we are going to do. We are first going to add a set curve radius node. This is going to let us change the thickness of it kind of over time. As you can see, it's letting us control the radius. And what I want to do is I want to control this as we go up the curve. So I'm going to use the spline parameter and use the factor for this. What I want to do is I want to say take the top 10% of it, so from 0.9 to 1, because the factor goes from 0 to 1, from 0.9 to 1, and make it go from 1 to 0, so it kind of pinches. You're going to see it's not actually doing that. It's actually starting from the bottom and working all the way to the top, and this is because it's only composed of 2 points. So if we resample our curve and give it 100 points, you could see from 0.9, 90% of the way up the curve, it's going to start pinching, and we can kind of control this. To control the shape, instead of making it kind of linear, you can either smooth the step, or to get even more control, we can use an RGB curves, which will let us kind of round the top here, and you can change where that begins. By the way, you can also do complicated shapes like this, but this is how we do the thing. And now in the next step, we need to actually make it look like a cactus, so we're sweeping a star instead of a circle. So in this part, we get more of the cactus looking shape by sweeping a star instead of a circle along our curve, and let me show you how to make this star. So let me just open the project. What we have so far is a curve and a circle sweeping along that curve. To make that circle into a star, here's what we're going to do. I'm going to set position because I want to kind of modify it, and I'm going to modify this by taking the position and what is a star. It's like some parts of it are kind of squished inwards. So I'm going to use a vector math operation. I'm going to scale it, if I can find scale it inwards, but that kind of takes the entire circle and pinches it inwards. I want to say only do that for every other point. So in the selection, what I can do is I can look at modulo 2 of the index. What this means is it's going to see which ones are divisible by 2, so it's going to go odd, even, odd, even, odd, even. So every other one, it's going to apply the scaling inwards. And this isn't it, because we can actually get a bit better. We can take this curve and fillet it. Don't know how to pronounce that. Set this to poly and limit radius. And we want to make sure the radius isn't too big, so something like this. Add more points, and we can get just a bit smoother like that, so that when we use our curve to mesh instead of a circle, we use the star, and this gives us the cactus-like shape. Next thing I want to do is it kind of looks like a straight up thing. I want to kind of have a profile that looks like this. So it kind of gets bigger in the middle and pinches at the top. So let me show you how to do that. So as promised, in this part we are going to give this thing a bit of thickness in the middle so it's not so even, and let me show you how to do that. So before we had the shape, but it's kind of perfectly straight, and we want to fix that. So what I can do for the curve radius is I can add an influence. In other words, I can take this and I can multiply. Again, this is going to control the thickness of it. I'm going to multiply by the factor, which goes larger as it goes up, going from 0 to 1. Except what I want to do is I want it to have 1, 1 on the endpoint, so nothing changes, and in the middle it gets thicker. To do this, I'm going to use a color ramp. There's a couple ways to do this, but color ramp works for me. So I'm going to have 2 white handles, and then fun fact, if you had a handle in the middle, you can actually type a value larger than 1, like 1.3 is one that I found was pretty good. So in the middle, it's going to go even brighter. In other words, it's going to increase. You set this to ease or one of these others, and it's going to smooth it out and give you some curvature. So the more you increase this value, the more curvature you're going to get. In the next part, we're going to break up this shape a little so it has a bit of noise. Let's do that. So you can see that this cactus shape is a bit distorted now. This is because I added some distortion, and let me show you exactly how to do that. So we already have this kind of tapering looking thing. We just want to add distortion. To do this, go to the very final node now that this is a mesh, and we are going to set position, because again, we're altering the position by an offset of a noise texture. You can use any source of randomness. I like a noise texture. In general, this is going to add a value between 0 and 1 on the X, Y, and Z axis, so we have to recenter it, because you can see it's kind of moved off to the side. Since it's adding between 0 and 1, I'm going to subtract by, or I'm going to add negative 0.5, so on average it moves to the middle. And if we take this and scale this vector, or the offset, you can see we can control the size of this effect. For my cactus, I'm going to have a detail of 4, so it has a bit more detail, as you can see. I'm going to bring down the scale so it's more low frequency detail, and I'm just going to mess with this until I like kind of the amount of influence. So this is before and this is after, just adding a bit of noise. And in the next part, what I want to do is I want to start adding the needles to the thing. So we need to make a needle. So here you can see the needle shape I'm going to make. I'm going to take this and I'm going to distribute it over the cactus, but I need to show you how to make this needle shape. So here's how you do it. It's actually pretty simple. I'm going to start off with a bunch of points. So I'm going to use a points node, and notice it's going to be separate from everything we've done here so far. So I'm just going to actually Shift P to put that in a frame. I'm going to have a bunch of points. So let's say we have 6 of them. And for each of these, I need to make a needle that's oriented a random direction. So I'm going to instance on each of these points a curve line, since I want some curve control in a bit. And you can see it's going from 0, 0, 0 up to a unit 1 on Z. So we have 6 of these overlapping. Take this, add a rotation of a random value going from negative 1 to 1. This is going to randomize the distribution, and you can actually change the seed to get different kinds of looks going on here. But for each of these, I want to actually give it thickness again, just like we did before. So I'm going to realize these instances so they're actual curve objects. I'm going to curve to mesh. And just like before, we can use a profile curve of this time just a mesh circle, or no, a curve circle. Can't believe I made a mistake. A curved circle is enough of a tiny radius, and it actually doesn't need to have that much geometry. Finally, since this is a needle, it should be thickest down here and then pinching at the top, which is kind of something we've dealt with. To do that, we are going to set curve radius by the factor, since that tells us how far along the spline we are. And you can see it's pinching down here and then increasing. I believe there are 2 ways to fix this. You could either do the map range thing I showed you before, or a bit fancier, I believe we can reverse the curves. There you go, and that does it. So there you go. We've made the needle. In the next part, I don't want them all to be exactly the same. I want to randomize their lengths. Actually, we can do that this part. Screw it. Go to scale, go to random value, and go between, like, I don't know, something like between 0.6 and 0.1. So there we go. Now we have a needle thing, and in the next part, I want to randomize their thickness. So not every single spline has the same thing. So let's do that in the next part. So it turns out that randomizing the thickness of each of these needles so it's not exactly the same is actually very simple to do. So again, we have the set curve radius. All we need to do is we need to take this, we need to multiply it by this like factor that we reversed curve for. So this is going to be the general thickness. Notice that it still ends at 0, because when you multiply something by 0, it remains 0. It just changes the base. All I need to do now is use a random value. But because I want them to generally be 1 or thicker, I'm going to have a random value between 1 and 3. So some of these are going to be bigger, some of them are going to be smaller. And you could like go into detail here and have the needles be kind of like this, but I assume they're straight lines. So we are going to take this now and distribute it on our cactus, although it can only be on these ridges here. It can't be everywhere. So we need to make a selection for that, and I will show you how to do that in the next video. So here you can see our cactus, and I've actually made a special selection that shows exactly the ridges or the protruding part of the cactus. Another way to think about this is we did have our star from before, and I am highlighting the tips of that star, which are going to turn into the ridges. And we need to do that so we can actually distribute our needle. So I actually have the needle from before on those ridges. So let me show you how to do that. Just had to do a bit of an explanation so you know what we're doing. First of all, I'm going to take all these needle nodes that we made, and I'm making sure that I select all of them, and I'm going to move them off to the side. So we have the needle and we have the cactus. Specifically, I want to look at the cactus and make the special selection. So if we look at this filleted curve, what I can do is I can say, let's isolate these ridges. To do that, I'm going to look at the spline parameter. So as we go along this, I want to visualize this filleted curve, and we can see the spline parameter on top of it. So you can see it's going from 0 to 1. I want to take this and make sure that there's 1 per ridge. So instead of 1 0 to 1 cycle, I want this multiplied by the number of ridges, which is, I think, the number of stars. It's either that or divided by 2. So we had 32 here, which again is going to be the number of, ridges, allegedly. Take this and connect it to the multiplication, and then we need to send this through a fraction. So it goes 0 to 1, 0 to 1, 0 to 1, and you can see it's not working. Why is it not working? It's because we need to resample the curve. Anytime we do something weird to it, like the fillet and all that, we need to resample. So I'm going to resample the curve by a factor of, I don't know, 1,000. It's not that computationally expensive. But you can see it's going from black to white, kind of. It's very subtle. 32 times, okay? So if we now take this and make it a bit more distinctive, which part is our selection, we can take a color ramp, set this to black at the endpoints and white in the middle. You can now see, well, once we kind of crunch this gradient, you'll be able to see that we've isolated part of this selection. I think we have twice as many as we need, which makes sense because there's ridges and valleys, so we need to divide by 2 to only have ridges. So I'm going to take this, I'm going to divide it by 2, and it looks like it needs a bit of an offset, so I'm going to do a bit of an addition. So something like that isolates these ridges. But I don't just want to isolate the ridges of the star, I want to get it for the mesh, which we can view. Let me try to view it. You can see it's black because it doesn't actually carry over that information. So what we need to do is we need to somehow capture this before it gets converted into a mesh, right? We have a curve to mesh. To do that, we need to use a capture attribute. So we have this attribute for the resampled star. We are going to select that right there. This is what's going to be sent to the curve to mesh. And now when we view this, it should exactly show the ridges of our thing. And because we did this before we applied our set position noise, it kind of flows with this kind of jagged noise thing. Especially, you can see it's like, it's dependent on our thing. But the number of ridges now should not matter as long as it is an integer. So if I make it 24, we're always going to have the ridges selected, it seems. So now we've made our selection, and now we want to distribute our needles on top of our special selection. So let's get to that. So the first step for taking our needle and distributing it on top of the cactus with that selection from before is we need to distribute points exactly on the ridges. So in this part, I'm going to show you how to distribute points not just everywhere, but spaced out along the ridges. And it's actually not that complicated to do. So if I go to the before, here's what we need to do. We have our cactus, and by the way, at this point, I'm going to take our needles, Shift P to frame it. So we have our needle and our cactus. And for our cactus, what I'm going to do is I'm going to distribute a bunch of points on faces. And I mean a lot of them, like 5,000. You can see that it's actually being applied everywhere, especially if we set the point radius and make it a bit smaller so you can see. I'm going to make it like 0.01 or something. You can see it's being distributed all along this cactus. We only want it for our selection. So remember, we captured this attribute from before, put that in the selection, and now you can see it's exactly on the ridges. However, we kind of have this clumping and we have points over points. And I know what you're thinking, just use a Poisson disk distribution. Again, making sure this is a large number. And that could kind of work, but it's still kind of a bit too close, even if we kind of do that. So you could either use a Poisson and do this, or what I think is even easier and I think this is the algorithm under the hood, is you take this and then you merge by distance. And the merging is going to create these nice bands. So again, if I shouldn't have deleted that, but the set point radius, I'm going to bring it back down to 0.02. You can either use a Poisson disk like I showed you, or you can use this merge by distance, which I feel like is a bit more intuitive, but I think might technically be more computationally wasteful. Either way, choose the spacing of your points, and in the next step, we are going to put things on top of things, needles on top of cactus. See you there. So you can see that I put my points on top of the cactus, but I did it with some random distribution and stuff like that, so let me show you exactly how to do that. So remember, we have all these points from before, they're in these bands, and we have our needle shape. Let's put one on top of the other. So for these points, we want to instance on points, so we want to instance on, well, you want to use the right node, instance on points. For each one of these points, we want to use this as a instance, so it's copying. First issue, you can see they're way too big, right? So for the scale, should have made a joke there saying they're too small. For the scale, we want to use a random value. I'm using a float input, one-dimensional, so that it's the same x, y, and z uniform scaling. And I'm just going to bring this down to like 0.12. I know this number because I played with it before, and I don't want any of these to be invisibly small, so I'm going to have the minimum be 0.05. So you can see we now have our needles a reasonable size. I joined them with the cactus, but they're pointing the wrong way. I want them pointed outwards towards the normal. You might be tempted to take your normal from distribute points on faces and connect it here. Would not recommend it. Instead, take the rotation and connect it to rotation. This is going to do effectively what we want, but they're still kind of all pointing the same way, kind of. So you can see this is going down here, down here, down here. It's all the same. So for this rotation, we can actually randomize it a bit. I'm going to vector math, add a random value vector, and set this all to 0. So to start off with, one of our axes, it's not x, it's not z, but it's y, is going to spin it about the normal. So I'm going to rotate a lot there so that they're all kind of facing different directions. And then I'm just going to add a bit on the x. So going from -1 to negative 0.1 to 0.1, and negative 0.1 to 0.1 on the z. This is just going to add a bit of variation, and again, you can play around with the scale here to get what you want, or you can go back down to this merge by distance to increase kind of the needle count. But I think this this looks pretty good. So I think what we are going to do next is I think we're done with the cactus. And by the way, I just want to mention here, all of this has been procedural. We can change the number of ridges to an integer. That's very important. And it's going to keep these needles on the ridges. It's all procedural. In fact, I'm going to set a more reasonable number, like 26. It's all done, but now I want to make the pot for this cactus, because I think the cactus shape itself is done. Let's make a pot. So before we make the pot, I just want to take a moment to relax. This is the intermission. Think about what you've done so far. You've made a cactus in like an 11-part series, including part 0, and now you're actually at the easy part where we're just going to be manipulating a cylinder and then distributing some pebbles. So take a nice deep breath in, a nice one out, and continue on to the next part where we are going to make a pot. So before we make this pot, which is based on a cylinder, the first thing I want to do is I want to make a system where no matter where we draw our cactus, because remember it's a drawn on cactus, the cylinder goes to the base or the first endpoint of the curve, and then we replace it with a pot. So let's set up a cylinder that goes to the base of our curve. So recall, we have a curve, and all of this kind of creates a cactus. What I'm going to do is I'm going to add in a cylinder, and we're going to reshape it later, to make it look more like a pot. We're going to start off with a cylinder, and what I want to do is I want to position it in the correct place. To do that, what I'm going to do is I'm going to transform it by which vector, it's going to be using a sample curve, which is going to let us use the group input, which is the curve that we start off with as a curve, and I'm sampling it at factor 0. In other words, at the very beginning, we're going to take the position and connect that in right there. So now it should be at the beginning of the curve. To actually see this, I'm going to join this with everything else that we have so far. So now we can visualize. It's going to be a little hard to see because the cylinder is big, but you can almost see that it's kind of based at the beginning of this. And now we're gonna kind of have to just kind of reshape the thing. So I'm gonna take the scale. You could either bring down the scale, or actually probably makes more sense. Let's bring down the scale. Let's do it like that. So I'm gonna bring down the scale like this. We can also use a vector math to manipulate the incoming vector for the transform. And we can say move it down a little. We can also mess with the radius and the depth and all this. But I think something like that should look pretty good. So the way this works now is when we draw our curve, and make sure you can either like modify the existing curve or you can delete it and draw a new curve. The cylinder is going to go to the base here. As you can see, no matter how complicated our cactus becomes. So now the name of the game is actually turning this into a pot, which we will do in the next part. So let me just draw a basic thing for our cactus. That looks good. There we go. Now let's make a pot. Okay, so we've made a system that puts a cylinder at the beginning of the curve, but we want that cylinder to be a pot, so let's reshape this thing. So take the cylinder, and first of all, let's go into wireframe mode so we can see, add some resolution to this so it's a bit more circular, and add some side segments. I would go to something like 50, because we're going to really be manipulating the geometry. And speaking of manipulating geometry, every time we're moving around points, we use a set position node, and the name of the game is going to be expanding this on the X and y-axis radially, or spherically in a sense, to kind of mimic the shape of a pot. To do this, I'm going to take the position, and I'm going to separate out the Z component. So we're basically going to make this go bigger and smaller, so it'd kind of be bigger up in this area. It would be kind of curved down here to make a lip. We're going to do that based on how up and down we are on the Z-axis, right? So if we take the Z-axis and we do a map range, because remember, the way this is working right now is the cylinder has a depth, or in other words, a height of 2. So it's going from, if we look at just the cylinder, it's going from -1 to 1. So I want the 0 to 1 gradient. The way we can do that is we can take this map range, map from -1 to 1 to 0 to 1. Which means if we now take the position and we run a vector math, so I'm going to take our position and I'm going to multiply it by a custom vector. That vector is going to be one where we can control the x, y, and z. Z is going to be unchanged, and x and y is going to be subject to this. When we connect this, you can see it's pinching at the bottom because z is equal to 0 in our remapping. And then it's increasing up to 1. And again, it's only modifying the x and y components. So now we're kind of have to reshape this in a sense. So to do this, what I'm going to do is I'm going to take this map range result, and probably the easiest way to do this is send it through an RGB curves. So you can see this diagonal line kind of matches the diagonal line of this. If I curve it, it will curve. So to make a pot, what I'm going to do is I'm going to kind of bring this up so it kind of has a diagonal thing. And at some point we need kind of a harsh transition, something like that, to make it more of a pot. I would recommend setting these handles to linear, which makes them more angled. And you can see what I'm doing here. I'm kind of shaping this hardcore lip here. Probably the first time you heard hardcore lip in a Blender tutorial. Do something like that. And then I'm also going to add a point at the base here. And just add a bit of curvature. And then flatten it up at the top. And the idea of this is you can see it's kind of subtle, but it's making a bit of a curve here, a bit of a lip. And I think that's pretty good for our pot shape. You could get a bit more complicated, right? You could add like a point here and it caves in. Maybe let's actually do that. I'm going to add a couple points and then a point in the middle and have a bit of a dip. This is just to add some extra detail to our thing. And again, make sure to set some of these that you want to be linear to linear. So I'm just resetting these. And now we have a more complicated looking pot. I think the last thing we want to do is we want to kind of give this thing thickness and separate the top component. So in the next part, let's separate this top component and then do the extrusion. So now that we have our pot object that we made with these nodes, what I want to do is I want to separate this top component from the rest of the pot, because that is going to be where the pebbles are, and the rest we're going to extrude. So here's a trick to do that. So the last node of this pot, what we are going to do is we are going to separate, because I want to have two selections. We are going to separate geometry by where the selection is equal to, and here's a bit of a fancy trick, we're going to see where the vector of the normal, so we're looking at the normals, is equal to this vertical 0, 0, 1 vector. Make sure that this is set to face since we're trying to isolate a face. And you can see now we have the top of the pot and then the rest of the pot, kind of like we hollowed it out, but we still have the bottom of it is preserved. Notice that we could not have done this with a cylinder where we say, oh, cylinder, just have no caps, because that does it for the top and the bottom. Right, this method actually separates out the pieces, and the reason it works is because the normal at the top here is exactly pointing upwards towards 0, 0, 1, and no other face is doing that. Even the bottom one is pointing downwards. So that's the only one that's equal to it, and that's why it separates the selection. And now what we can do is we can say, oh, extrude one and distribute pebbles on the other. So in the next part, let's extrude this pot and give it some thickness. So in the last part, we took our pot and separated it into the top and bottom component, and what I want to do now is with the bottom component, give it a bit of a extrusion so it actually has thickness. To do this, here's what we are going to do. And it's not as easy as just adding an extrude node, and I'll show you why. So we're going to start off, yes, with an extrude node. Make sure this is not set to individual, because it makes it weird. And bring down the extrusion to something that is roughly the thickness of the pot that you want. Now we have this, but you're going to notice, if you look very carefully, it's not a solid object, which I guess isn't that important for this render, but I do want it to be topologically sound. In other words, what I mean is if we look at the face orientation, the outside's fine, it should all be blue, but you can kind of see this red exposed. We don't want that. So what I'm going to do is I'm going to take the same selection from before and flip the faces. So now if we look at the face orientation, it's reversed. So here's this one and here's the reversed. What I'm going to do is I'm going to merge these together so we can actually just join them and then run a merge by distance to connect the close points, and now we have a solid mesh that is nice and blue everywhere. In other words, it's kind of like an airtight mesh that you can use for simulating and stuff like this. This is what we are going to connect with everything else, and I know we have a bit of node spaghetti here, so let's clean that up too. So here we have our pot. Again, we don't have this top section yet because we haven't included that yet. We have our cactus and our pot. Let's move some of this. I believe this is all for the needles. So I'm going to put it inside of this frame. Yeah, this is our needles. This is our cactus. This is everything joined together. We have our pot that's nice and extruded, but we do have yet another issue, which is it's kind of shade flatted, right? And if I want to run this through a set shade smooth, it's going to kind of smooth everything, creating kind of a weird upper lip because the geometry doesn't have much going on up here. Not much going on socially. So in the next part, let's work on the shading of how to make some parts shade smooth and some parts not shade smooth. So if you remember, our pot actually has a major issue, and that is that the set shade smooth is applied everywhere, including the upper lip, and we need to fix that. To do this, we are going to enable set shade smooth, but we are going to do it for a custom selection. So we're going to look at the unsigned angle. In other words, we have access to this edge angle, so for every two faces we have an edge and we can look at the angle in between them. I want the unsigned version, and we can look at where this is greater than or less than. I believe we want less than some value. And this is going to make a threshold for where the smoothing happens. So you can see as I decrease this, some of it is set shade smooth, some of it's not. And as we increase it, the upper lip gets the issue at a certain point. So I'm just going to reduce this until it does not have it. So we don't want it up here, but down here. So in other words, here's before on the upper lip, and here's after. So now we have a bit of a rim on the top. And that should also, yeah, that should just, I guess, clean up the top. So I guess the next part now is including, and we can actually start this right here. We want to now join this with our other selection, so the top of it, and I want to like move this down and distribute some pebbles on top of this. So let's do it in the next part. Okay, so we're at the final leg of this tutorial series. We have this top selection, and what I want to do is I want to move it down inside the pot just slightly and add some pebbles on top. So recall, we joined this at the very end of the last tutorial, and what I can do is I can literally transform this a little down on the z-axis, so it's kind of inside the pot in a sense. And now we want to distribute points on top of this. For each point, use a sphere or something like that to make a pebble. So I'm going to distribute points on faces. In this case, we want a lot of points, maybe even 1,000, if not more. And for these, I'm going to instance on points, and we're going to deal with the fact that it's going to be kind of popping out of the pot a little in a bit. I want to instance on points something that kind of looks like a pebble, and I'm going to use a UV sphere for that. Of course, we need to bring down the radius so our spheres aren't as big, and we can use less geometry by making them 8x4 resolution. I'm still seeing a lot of gaps here, so let's increase this to 5 times the amount of density, and that should help with that. And just to make this look a bit more sporadic, for the scale, we can use a random value right here. None of them should be at 0, but maybe 0.5. So now they're not all the same size. If we wanted to be fancy, by the way, we can use a random value as a vector and have them randomized on the x, y, and z axes. And I'm seeing we still have some gaps here, so I'm going to make this 7,500. And I think that's pretty good. I think maybe I want to do one more round of randomization, not necessarily with noise, but I want some pebbles to be a little higher than others because, you know, they're all kind of the same height at the moment, and then I think we will be done with this tutorial series. But so far, I just want to show you, we can draw this. So let me actually look at all the points, delete them. We can draw this, and it's going to add a pot with everything and the cactus in the correct place. And we can also edit this, extrude it, do all these kinds of things. So in the next part, let's take care of the pebble randomization. So for the final thing for our pebbles, I want some pebbles to be higher than others. So in other words, we have to move them towards the normal, and this will make it look less consistent. So when we distribute points on faces, which looks like this, what I want to do is I want to set position. Anytime we're moving points, we're setting position using an offset of the normal, which you're going to see moves them upwards because the normal is pointing at 0, 0, 1. That's how we isolated it before. But I don't want it to be this strong. So to modify this, I'm going to scale this effect, this normal, I'm going to scale the vector by a random value, which actually creates a distribution of a cylinder. But I want these to go up on the normal between 0% and maybe like 10%, which will be more visible when we instance on points. So you can see some points are on top of each other and some are not. So I can kind of do something like this. And let's actually see this in the context of the pot. So you can see some of them are kind of going outside the pot a little. I want this to be a little less strong, so 0.02, and maybe it can go downwards to negative 0.01. So in other words, what this has done, so let's see the before and after, is it went from this flat thing to some of them are raised and some of them are not. Let's go from negative 0.01 to 0.01. So it's a bit of a subtle effect, but it gives it more like three-dimensionality. That makes it look more realistic. And by the way, I think that's the final component of our modeling. In the next tutorial, it's not over. Let's do a bit of cleanup and then let's end this thing for good. Oh, maybe one thing I should do before we end this is for the UV sphere, we can run a set shade smooth, just so they look like nice pebbles. So let's do some cleanup and I'll see you on the next tutorial for that. So everything that we've done to this cactus has taken a lot of nodes and it has kind of turned into a mess. So let's do a bit of cleanup. All these new nodes that we added recently, basically all these ones at the top, I'm going to Shift P, put them inside a frame. And what you see now, and let me just move this group input back a bit, is we have 3 frames. And we kind of join them all together at the very end. This looks like nonsense, but here's how I interpret this. The first frame is our pot and pebbles, the second frame is our cactus body, and the third frame is our needles, and we just join them all at the end. It's nice to have these separated because we can do separate materials for each of these, and maybe I'll do materials at some point if people are interested. But we can clean it up into 3 frames, And you could actually do it in node groups, but I like to have my nodes nice and exposed. Let's give these some names. So we can select this, hit N, and in the frame label, we can call this pot and, where's the and pebbles. And you can see it makes this very, very tiny label. Maybe we can give it a color so it looks different from the others. For the second frame, we're going to call it cactus body. And what color would a cactus body be? I guess it'd be like green. And then finally, for the needles, so I'm going to I'm going to label this needles. I'm going to do kind of like a yellowish color, because that's what I would imagine needles to be. So we have this, and I guess the pebbles are going to be this kind of reddish brown, something like that. And this is how you organize the nodes. By the way, to clean this up just a little, I guess group input is used in both of these frames. So I'm just going to connect these, delete this, and make group input outside of this. So really, we have group input feeding into all of this, joined together, and then feeding into a group output at the very end. So that is our cleanup. Let's also call this cactus generator. And that should be good for the cleanup. I'll see you in the outro. So you did it. You made it through this 20 to 30 part tutorial series. I'm not sure how long it is, but kudos to you. You made it all the way through. At this point, I want you to, in the comments, tell me, do you like this format of me dividing it into like a bunch of tutorials? Because this is my first time doing it. Let me know if you like it. Do you like the flow of it? You can actually absorb each part as its own thing and actually follow along. Tell me what you think, and also obligatory promotion at this point. If you want the blend file for this, or if you just want to support what I do here, making free tutorials on YouTube, please check out the link in the description for Patreon. That is the best way you can support what I do here. I know some people give super thanks and all that, and that is amazing. Patreon is the best way to support. So you can also get the blend file for this, which is a bit of a bonus. So thank you for watching, and I will see you on the next tutorial series. Really do let me know what you think of this format.